Okay, so I have this lovely rational equation. Again, why is it rational? Because it contains fractions. I can't call it linear or quadratic because the variables are in the denominator, and that's not your definition. If the variables were all in the numerator, then you could call it linear or quadratic. So we just call this good old rational. The problem is when your variables are in the denominator, we know the denominator of a fraction can never become a 0. So therefore, you have to come up in front and state the restrictions. What the answer for x cannot be. So we'll take our first denominator, and to tell me what the restrictions are, we set our first denominator equal to 0. Because that's what the word undefined means. What number makes this denominator equal 0? I'm going to solve, and my first restriction is x equals -2. If x was the number -2, -2 plus 2 would be 0. 1 divided by 0 does not exist. This cannot be the answer when I'm done solving. I'll take my second denominator, x squared minus 4. I want to know what makes this fraction undefined, which means I want to know what makes the denominator equal 0. Because this is a square, we have two solutions. I'm going to solve this quickly doing the square root method. I'm going to add 4. I get x squared equals 4. I'm going to square root both sides. I'm going to get x equals plus or minus, and the square root of 4 is 2. So I know if I substitute in here a 2, the denominator would become a 0. If I substitute in a -2, the denominator would become a 0. Therefore, these two answers cannot be what x is. My third denominator is x minus 2. So I take x minus 2, I set it equal to 0, and I get my restriction x equals 2. Again, the word restriction means what the answer for x cannot be, because it makes the denominator become a 0, which makes the whole fraction not exist. That's what the word undefined means. The fraction doesn't exist. Now, don't tell me there are 4 restrictions here, because plus or minus 2 means one of the restrictions is positive 2, one of the restrictions is -2. So we have 2 restrictions. X, the restrictions on x are 2 and -2. I'm telling you up front, these cannot be the answer when I'm solving. Okay, now we're going to solve this equation. Solving means to get x by itself. Now we have a huge problem. To get x by itself, the first thing we have to do is get rid of the fraction bars. To get rid of fraction bars, you have to do the opposite operation of division, which is multiplication. But to keep balance, we have to multiply all the fractions by the same term. That's your least common denominator. To get the least common denominator, all your denominators have to be in lowest terms. They have to be prime. Is x plus 2 prime? Yes. We cannot break that down by factoring. There's no GCF. It's not a difference of perfect squares. It's not a trinomial. We leave it. Is x squared minus 4 prime? No, this can be factored. What rule of factoring can we use? That's right, it's difference of perfect squares. So we can replace x squared minus 4 with x plus 2 and x minus 2. Now it's in lowest terms. Is x minus 2 prime? Well, there is no GCF. It is not a difference of perfect squares. It's not a trinomial. So yes, it is in lowest terms. Once your denominators are in lowest terms, to get the least common denominator, the LCD, you take the most of every prime piece, of every prime term. I have 1x plus 2. I have 1x plus 2. I have no x plus 2's. I must need 1. So I write, I'm going to need an x plus 2 for the LCD. That's not my only prime piece. I have no x minus 2's. I have 1x minus 2. I have 1x minus 2. So I also need 1x minus 2. So your LCD is x plus 2 times x minus 2. We are not going to multiply this out because we're going to do the division first. If you do this correctly, what's in the denominator should divide out with the same term in the numerator. X plus 2 divides out. I'm left with 1 times x minus 2, which is x minus 2. Bring down the equals. Over here, x plus 2 and x plus 2 divide out. X minus 2 divide out. I'm just left with 4. Bring down the minus sign. Okay? x minus 2 and x minus 2 divide out. I'm left with 1 times x plus 2. But wait a minute. That's not just a 1. Remember we talked about this? This negative floats to the top. So this is negative 1 times x minus 2. Well, negative 1 times x is negative 1x. Negative 1 times 2 is negative 2. Now, you don't have to write the coefficient of 1. I'm just showing you that's where it came from. A negative times a positive is a negative. Now, I'm going to collect like terms. So on the right side, 4 minus 2 is 2. So I'm going to leave the negative x. I'm going to put my positive 2. Miss Black likes her x's on the left side, so I move by doing the inverse. I get 2x minus 2 equals 2. I add 2. I get 2x equals 4. I divide by 2. I get x is 2. So you did the process correctly. You solved correctly. You got x isolated. You got x is 2. But you told me here the restrictions. You told me up front, if x is 2, it can't be the answer. And the reason why, ladies and gentlemen, is if you go to check it. If we went to check this equation, and we substituted in here a 2, we would get 1 over 2 plus 2 equals 4 over 2 squared minus 4 minus 1 over 2 minus 2. So we knew this is our answer, and we checked it. We would replace an x with the 2. Well, this will work. This will give us 1 over 2 plus 2 is 4. That's a fraction. Watch what happens here. We get 4 over. What's 2 squared? 4. What's 4 minus 4? 0. 4 divided by 0 doesn't exist. You cannot take 4 items and divide it into 0 groups. So there is no fraction here. And if there is no fraction here, you can't finish the check. And if you can't finish the check, then you can't prove to me this is the solution. So the rule is, if you get an answer for x on a rational equation, and it's the same number as what you stated as the restriction, you throw this in the garbage, you cross it out. There's an official name for that. It's called the extraneous solution. Extraneous means useless. That's useless. I can't use it. If you can't use it, and I ask you, what is the answer for x? All you can say is no solution. And you could write that in words or use the symbol. Okay, see you in the next module.